So this is a second example of everything from section 3.2. So I think in this video, I may just do part A and B, and then start a separate one doing part C and D. So let's talk about finding relative minimum or maximum using the second derivative test, okay? But we need to start with critical values. So let's find the first derivative. Which is 20x cubed plus 60x squared, and set this equal to 0. Now let me see, they definitely have the greatest common factor, right? The greatest common factor looks like 20x squared. So what I'm going to do is I'm going to factor out 20x squared in front of the parenthesis, and write down the leftover inside this parenthesis. So first, divide 20x cubed by 20x squared. Only thing left is just x plus 60. Looking at this now. Hold on. Looking at. Oh goodness! Stop erasing my 2. I'm looking at this. 60 divided by 20 is 3. And x squared divided by x squared is just 1. So no more x's now. Okay. Alright, so I got it factored out pretty nicely. We're going to set each of these factors equal to 0 now. Okay. So first, set this equal to 0. Well, you know what? I don't really have to set 20 equal to 0. I can just say x squared equals 0 when x is equal to 0, right? So the first critical value is x equals 0. The second critical value is from x plus 3 equals 0. So if I subtract 3 from both sides, I get the critical value of negative 3. Now, if I'm going with the second derivative test, I need to find the second derivative. Okay, but hold on. What was the first derivative? Let me write this here. The first derivative is 20x cubed plus 60x squared. All right, now let's do the second derivative test, okay? Take the derivative of this. That will be 60x squared plus 120x. We're going to plug in this x of 0 and x of negative 3 into this second derivative to get their signs, okay? So what is g double prime of 0? If I plug in 0, I get 60 times 0 squared plus 120 times 0. Uh-oh, we got a problem. This is 0. Inconclusive. Uh-oh. Because second derivative has to come out to be positive or negative for us to say if it's a relative minimum or maximum. If it comes out to be 0, we have to go back to the first derivative test to confirm if this can be a relative maximum or minimum, okay? But hey, let me take care of the other one first. I'll do the other one and then I'll come back and do the first derivative test. All right, if I plug in negative 3 into this second derivative, I will get 60 times negative 3 squared plus 120 times negative 3. Oh, that better not be a 0, you know what I mean? All right, I'm going to get a calculator open to type this in, the red part. I'll just use this calculator. 60 times negative 3 squared plus 120 times negative 3. All right, a positive number What does a positive number tell you? Let me go back to the second derivative test real quick. Remember, positive second derivative tells us that this is where relative minimum happens. Yay! So we found the relative minimum point. No, not the point just yet. Where the relative minimum happens. Relative minimum at x equals -3. By the way, this value that we got doesn't really, don't look at it. Don't even look at it, okay? Don't say 180 is the relative minimum value. Just look at the sign of this number. That's what tells us that this is where relative minimum happens. So if we want to find the point, we have to plug in -3 into the original function, okay? So, we have two things to take care of now. This green inconclusive part. I now need to go back to the first derivative test. So sketch a number line and plot the critical values here, okay? The first critical value that is smaller was -3. So I'll put the -3 right here. And the other critical value, that little troublemaker, that was inconclusive, is 0. So what I'm going to do is I'm going to run the first derivative test. Okay, I'll do first derivative test using this first derivative. Let's check the sign of the first derivative to the left, to the right, and in the middle to identify the increasing and decreasing interval. So I will pick x equals -4. So that will be 20 times -4 cubed plus 60 times -4 squared. All right, I'll get a calculator and I'll type that in. I just want to know if this is positive or negative. 20 times -4 cubed plus 60 times -4 squared. -320. So this comes out to be a negative number. Now, if the first derivative is negative, we know this interval is decreasing. What we just found above, though, is that -3 is where relative minimum happens. So if this was decreasing to the left, we're going to go back up to increasing after we hit -3, right? We're expecting that. But all right, let's confirm that answer by plugging in a number that is bigger than -3, but smaller than 0. So a number in between these two. What number is like that? I will do -2. So if I plug in -2, I'll get 20 times -2 cubed plus 60 times -2 squared. All right, I just want the sign of this, okay? I just want the sign. So if I change this to -2, the sign is positive. So as we expected, the graph changed its behavior to increasing as it hit -3. Because the second derivative test told us that this point is a relative minimum. So everything is working out so far. But this wasn't helpful to us when it hit x equals 0. The second derivative test was inconclusive for the critical value of 0. So what's going to happen? Is it not going to go down from that point on? So we will plug in a number that is bigger than 0 to see if it is increasing or decreasing. So let's pick a number. I will pick x equals +1. All right? If I do 20 times 1 cubed plus 60 times 1 squared, that's positive, right? Because this is really 20 plus 60, that's 80. 80 is a positive number, so this is increasing. I see. Our critical value of x equals 0 was not that special after all. It still increases. So the behavior did not change as it hit 0. It was increasing and it is still increasing. So the critical value of x equals 0 is not a relative minimum or maximum, and that's okay. It's just it kind of stopped increasing for a while, right? Like it was going up and it took a quick break, just took a break, and then it went back up again. So how do we, I think we are done answering part A and B. Let's see. Give the coordinates of any critical points and classify each point as relative maximum. Oh, okay, we did not do that just yet. We need to give them points. So this is what we have so far. We have the information that we have a relative minimum is happening at x equals -3, but we don't have the y value, right? So to find the y value, we will have to plug in that x into the original function. So it's a lot of work, different things to do. 5 times -3 to the 4th power plus 20 times -3 to the 3rd power. So we have a relative minimum, pretty low, at -3, -135. So that's one critical value point. Now, there was another critical value, right? Critical point 0. Now, what's the y value when we plug in 0? 0, 0. What comes out 0? Critical point 0, 0 is neither relative minimum or relative maximum. So we told them that even though it is a critical point, it wasn't special enough because the behavior from the left and to the right didn't change. It was increasing and increasing again. So we say this critical point, 0, 0, is neither a relative minimum or relative maximum. They want us to also identify intervals where the function is decreasing or increasing. I will do that part, and that's it for this video. Okay, I'm going to start over again to do the point of inflection and concavity. So we got the picture already all lined up. So let me just write the answer. This is decreasing on -infinity to -3, right? And this is increasing on -3 to 0 first, right? But also it stopped at 0, but it starts going back up from 0 to positive infinity. I can't remember if my lab will ask you to just write it as a single interval, like from the far left point to the far right point, so that you just write -3 to positive infinity, or if they ask you to separate it with the u in the middle. Okay, so check out both. If you can let me know like what it wants, but I like separated because technically at x equals 0, it wasn't increasing, right? So that is it for the first two parts of example 2. I will stop and start another recording on point of inflection and concavity in another video.